546 ml. Check it. I have got this. And substitute this. They ask you to find volume at 100 degrees Celsius. Means V100 is equals to 546 means initial V0. V0 means 546 plus again V0 means 546 by 273 into difference in temperature, that's 100 minus 0, it becomes 100. On solving this, you will get it as 746 ml. This is the volume at 100 degrees Celsius. This is an important model also for final exam. Make a note of it. This is another important subtopic in states of matter, that's Graham's law of diffusion. Here the first point is about diffusion. Diffusion is irreversible and non-directional in nature. Best example is perfume. Once if you keep a body spray cannot come again into the same container, and it's non-directional. If you spray it on one direction, it does not go straight. It becomes random, and you will find the same fragrance even in corners also. Coming to next about effusion. Effusion is irreversible and unidirectional in nature. This is also same, irreversible and unidirectional in nature. Because it passes through a small hole, effusion passes through a narrow hole, and it will be in same direction. So here are the important note you should make this. Remember, this will make you easier to solve the numericals related to Graham's law of diffusion. That's rate of diffusion R is given by volume at certain temperature, number of moles by T means number of moles by time, volume by time, distance by time. This is the rate of diffusion. At constant pressure and volume, ratio of two rates of diffusion is given by root over d2 by root over d1. Finally, root d2 by d1, or root over m2 by root over m1, or root over m2 by m1, root over vd2 by vd1 means vapor density 2 by vapor density 1, or v1 t2 by v2 t2, v2 t1. Should find here. This can be derived from this. This can be derived from this based on moles and density. These two you should remember, and you should remember these terms. Then you easily can do the numericals based on Graham's law of diffusion. At constant temperature, rate of diffusion R1 by R2 is given by P1 by P2 into root over M2 by root over M1. You should remember this. At constant pressure, R1 by R2 equals to root T1 into root T1 by root T2. This is one term. Root M2 by root M1. This is another term. Remember like this. And here is another important line called based on atmolysis. Separation of gases present in a gaseous mixture by using Graham's law of diffusion is called atmolysis. Important definition, maybe asked in final exam, so I have made it. Then the numerical is atomic number of some gases are given. Which gas have highest rate of diffusion? Here they have given 7, 9, 8, 10. The atomic number 7 is nitrogen, 9 is fluorine, 8 is oxygen, and 10 is neon. Here we write it as O2, N2, F2 because it's a gas, not an element. So we should write it as general form N2, F2, O2. They have given highest rate of diffusion. Simply, if you see a boy, if he is so chubby and fat, he cannot run fast. If a lean boy or fit boy, he runs fast. Same. This have molecular weight of 28. This have molecular weight of something, and these have nearly 38.5. These have nearly 32, and neon have just 20, I think. 20, and this is a low molecular weight out of these all four options. Then it becomes option D. Simply make note of the options and you will find it easily for you. And the correct option is option D. That's D equals to Z equals to 10. To understand the Graham's law of diffusion, here is an important question for you. 2 grams of hydrogen diffuses out of vessel in certain time. The mass of oxygen that diffuses from the same vessel in same time under same conditions is. Here is the relation between number of moles and time. Means we should write the equation R1 by R2 equals to N1 by N2 into T2 by T1. Here we can write R1 by R2 as root over M2 by M1 because they have given oxygen and hydrogen. We can write this two, root over M2 by N1, N1 by N2, that's we can write as W1 by, under they have given same conditions and same time, then this two gets cancelled. It becomes W1 by M1 into M2 by W2 becomes, because here W2 by M2 becomes M2 by M1, sorry, W2 by W1. Then we can write here root over, then we can write this as W2 by W1 becomes root over M2 by M1 because here these two terms can be made as root over M2 by M1, this is separate, and W1 by W separate. One term may gets cancelled and it becomes W2 by W1 equals to root over M2 by M1. This is an important equation that we can solve based on questions, and this is important formula too. You should remember it. Remembering this may save our time. And finally, if you solve this equation, and you will get that weight of oxygen as 8 grams. Check it, it's 8 grams. And note this formula if you do not know this. And this is an important question. Actually, there will be many questions to find ratio of diffusion by giving vapor densities, ratio of rate of diffusion by giving molecular weight, and V1 T2 by V2 T1, that formula. But this is important. Here is another important question on Graham's law of diffusion. That's a uniform glass tube of 10 centimeters length connected to a bulb containing hydrogen at one end and another bulb containing oxygen at other end at same temperature and pressure. Both meet for first time at a distance of dash from oxygen. This is an important question, and a comedy question also will be present based on this question. That's from one side of theater crying gas will be released, and from another side laughing gas will be released at one particular row. The audience will be both crying and laughing. Then they all ask at which row both will be crying and laughing. Same here, this process you should do same in that question also. Here first let's draw the diagram. They have given as uniform glass rod. It has a length of 100 centimeter. Let us assume hydrogen from this side and oxygen from this side. We should find both the distance from oxygen. Then let it be here and that be x. However, it's 100 centimeter they have given. Then this becomes 100 minus x. 100 minus x. Here you should find the distance that's from hydrogen to oxygen. Means distance from the H2 by distance at O2. That is equals to root over molecular weight of oxygen by molecular weight of hydrogen. We can take like this. Then distance of hydrogen, that 100 minus x by 100 minus x by x is equals to 4, making it here 32 and it's here 2, getting it solved by 16, and root of 16 is 4. It becomes 4 here, and solving this x you will get as 20 centimeter. Make a note. Here is another theory question and logical question for you. 4 gas balloons A, B, C, D of equal volume containing hydrogen, nitrogen, carbon monoxide, carbon dioxide respectively, are punched with needle and immersed into a tank having carbon dioxide, which will collapse after some time. And the correct answer for this is AC, because hydrogen have low molecular weight and its the rate of diffusion will be high. And comparing the weights, hydrogen have 2, nitrogen is 28, carbon monoxide is 14, carbon dioxide is 44. Here H2 and carbon monoxide have low molecular weight and rate of diffusion will be high, and it will be entering into, and to compress this, water will enter quickly into this. As gas leaves quicker, water enters and the balloon blasts. This is the logic here, and low molecular weight gets collapsed easily. Here is important relation: rate of diffusion is directly proportional to surface area of all phase. This is important because as the surface area for rate of diffusion is more, then the rate of diffusion will be high. This is another formula you should remember for solving some of the numericals that are important. Remembering these formulas saves our time a lot. R1 by R2 equals to root over M2 by M1 into N1 by N2. Remember this formula and make a note of it. Here is another question. A mixture of 50 ml of hydrogen, 50 ml of oxygen are allowed to effuse under same condition till 90 ml of mixture left. Volume of hydrogen uneffused is. This is an important model. Here first you should take the relation R1 by R2. R1 by R2 is equals to root over M2 by M1. M2 by M1. It becomes 4 because oxygen is 32 and H2 is 2. After solving this, you will get it as 4 by 1. Here, volume of H2, you should find first the escaped volume. Here, effused, that is volume of hydrogen effused, that is equals to, taking here, it's 4 parts. To the total is 4 plus 1, that's 5, into the total volume, that's 10 ml is there. 90 ml of mixture left means it's totally 100 here, becoming 90, difference is 10. Then out of this it becomes 2, means 8 ml of oxygen is effused. If they ask to find oxygen, then it becomes 1 by 5 into 10. 5 get cancelled by 2, then it becomes 2 ml of, this is oxygen and this is hydrogen. Coming to the next question, the rate of diffusion of a sample of ozonized oxygen is 0.98 times that of pure oxygen. Find percentage here, not find percentage by volume of ozone in ozonized oxygen. Here also you should use the same relation. R1 by R2 is equals to root over M2 by M1. It is, if you substitute the terms here, they have given rate of diffusion is 0.98 times. If you are making this root into here, it becomes square, means 0.98 square is equals to root over M2 by M1. That means weight of oxygen by weight of ozonized, means mixed one. Solving this, we get weight of the mixed one, molecular weight of mixed means ozonized is 33.3 grams. Check it once. And to find here as volume percentage of oxygen, here the first thing is you should do 48x plus 100 minus x into, here it's 32. by total volume of 100 equated to 33.3. Like finding atomic weight by relative abundance, same model. 48 is the molecular weight of ozone, 32 is the molecular weight of oxygen. Let us assume it to be volume percentage X for ozonized oxygen, 400 minus X for the oxygen, and 33.3 is the molecular weight of ozonized oxygen. Finding this, you get it as X value is equals to 8.3%. It's 8.3%. Check it once. Coming to next, it's important Dalton's law of partial pressure. This Dalton's law of partial pressure is only applicable to non-reacting gases like carbon dioxide plus oxygen. This is one set. Nitrogen plus oxygen. This is another set. Xenon plus helium. This is another set. It is not applicable to reacting gases like NH3 plus HCl. This is one set. H2 plus Cl2 another set. H2 plus Cl2 another set. H2 plus F2 this is another set. NO plus O2 Xe plus F2. According to Dalton's law, pressure P equals to P1 plus P2 plus P3 plus and so on plus Pn. Here the term P1 equals to N1 by N into P. Here N1 by N represents mole fraction of first gas X1 into P. P2 equals to N2 by N into P equals to X2 into P. Here X2 N2 by N is the mole fraction of 2 represented by X2. Another important point, if any gas is collected over water, resulting pressure is, means we will get the pressure if you collect over water is pressure of the gas plus pressure of hydrogen vapor, H2O vapor, water vapor. Then to find the pressure of the gas, we should subtract pressure of water vapor from resulting pressure. Pressure of the P resulting pressure minus pressure of water vapor gives the pressure of the gas. Here, pressure of the water vapor depends only on temperature, but it is independent on volume and pressure. You should remember this point. Here are some of the numericals for you for understanding Dalton's law of pressure up to good extent. Here is the first question. A vessel containing methane on carbon dioxide in a mass ratio 2:1. Fraction of partial pressure of oxygen in total pressure. You should find here fraction of partial pressure of oxygen into the total pressure. Here to find, first we should find mole fraction of first gas methane. We know they have given it as 2:1, then 2 parts of weight by 16 is the molecular weight, then it becomes 1/8 for methane. To find for oxygen, here it's not carbon dioxide, it's oxygen. Sorry, typing mistake. First they have given it as 1 part, 1/32. Here to find the total mole fraction, N equals to N1 plus N2, it becomes 5/32. To find partial pressure of oxygen, mole fraction of oxygen by total number of moles into P. We know the formula, right? P1 equals to, we know, N1 by N into P. Using this into P. Using this here, substituting the values, we get partial pressure of oxygen to the P. What they have asked is 1/5. That's 0.2. Next question. In the mixture of gases present at 4 atmosphere contain 25% of hydrogen molecules, 40% of carbon dioxide molecules, and the rest are oxygen molecules. The partial pressure of oxygen in mixture is, here they have given percentiles, 25% of hydrogen, 40% of carbon dioxide, and the rest are oxygen. If you find this, other out of 100 minus 65, we get as 35%. It's 35% of oxygen. And they have given a total pressure of 4 atmosphere. Total pressure is 4 atmosphere. To find it, partial pressure of oxygen, you can write here percentiles also. In this here, based on this point, in place of mole fraction, we write volume or molecule fraction also. Here, if you write molecule fraction, that's 35% by 100 into 4, and we get partial pressure of oxygen as 1.4 atmosphere. Make a note of this question. It may be useful, and this question also. Here is another important question based on Dalton's law of partial pressures. That first question is equal volume of two jars containing HCl and H3 gas respectively at constant temperature and pressure. When one of the jar is inverted over another so that they mix up, the pressure in the either of the jars is simply zero. Simply zero. Because it is the most important question that I have asked many times in previous year's question. Therefore, at constant temperature and pressure, we know this equation NH3 plus HCl gives rise to NH4Cl. NH4Cl is a solid. Here, the twist is pressure exerted by a solid is zero, a big zero. So the answer is zero. Coming to next question. At 27 degrees Celsius, a closed vessel contains mixture of equal weights of helium, methane, sulfur dioxide. The pressure exerted by a mixture is 210 mm. If partial pressure of helium, methane, sulfur dioxide are P1, P2, P3 respectively, which of the following is correct? Means it's a relations. We know here. We know the relation P is directly proportional to number of moles N. Simply PV equals to nRT. If you assume volume and temperature is same, then we get P is directly proportional to N. By using that, here they have given total pressure of 210 millimeter. If you find it's based on, let us assume some constant equal weight X and substitute the weights here. First one is helium, that's 4. Methane, if you do the same, methane 16, sulfur dioxide 64. Substituting this, we get some least value. Means here it's 1 by 4. If you assume weight of 1 by 4, 1 by 16, 1 by 64. Then 1 by 4 is the highest value. Means it becomes P1. It's highest. Like this. Here is another important model. A cylinder containing hydrogen liquid and nitrogen gas recorded a pressure of 500 mm at 25 degrees Celsius. The volume of cylinder is reduced to half by forcing the piston downward at the same temperature. The new pressure recorded will be. They have asked, and they have given aqueous tension is 23 mm. Means pressure exerted by water vapor is 23 mm. Writing the pressure, resulting pressure PRP. Resulting pressure is the pressure of nitrogen plus pressure of water vapor. They have given pressure of water vapor as 23, and we need to find pressure of nitrogen. They have given final resulting pressure is 500 mm. And if you find here, we get pressure of the nitrogen as 477 mm of Hg. By using this, substituting this in the Boyle's law, P1V1 equals to P2V2. 477 is the P1, and we need to find volume V. P2 we require to find, it's the new pressure recorded, and volume is V by 2 because they have given it reduced to half. Initially it's V and finally it's V by 2. On solving this, we get P2 equals to 954 mm of Hg, and the total pressure is Pn2 plus P water vapor. Because they have asked again total pressure or resulting pressure, means we should include water pressure also. It becomes 954 plus 23, 977 mm of Hg. Here are another two important questions on Dalton's law. There are different models, and I am giving you the important models. A 600 ml vessel containing oxygen at 800 mm of Hg and 400 ml vessel containing nitrogen at 600 mm at the same temperature are kept in communication with each other through a stopcock, neglecting the volume of stopcock. Simply use this relation. P equals to P1V1 plus P2V2 by V1 plus V2. You get answer for this. And answer for this is 720. Answer is 720 mm of Hg. Check it. It's an easy question. Remember that here resulting pressure we call as resulting pressure equals to P1V1 plus P2V2 by V1 plus V2. Another question, 0.157 grams of certain gas collected over water occupies a volume of 135 ml at 27 degrees Celsius and 750 mm of mercury. Assuming ideal gas behavior, the molecular weight of gas is, here F means aqueous pressure, is 26.7 mm. Again, we should use the resulting pressure is equals to pressure of the gas plus aqueous pressure, or F. Here, substituting here 750 is equals to P gas plus 26.7. You will get here units is important. Units is important. Here, making it to atmosphere by dividing it by 760. We know the relation 1 atmosphere equals to 760 mm of Hg. 760 mm of Hg. Using this, we are dividing by 72 to make it as to convert it into atmosphere. Then we will get the pressure of the gas. Substitute it into PV equals to nRT. Make this pressure come here, P something value. It becomes, then multiplying it with volume they have given, volume by nRT, and finally you will get the answer as 13.2. Check it once. This is the last question of Dalton's law. A certain quantity of gas occupies 100 ml when collected over water at 15 degrees Celsius and 750 mm pressure. If it occupies 91.9 ml in dry state at STP, the water vapor of water at 15 degrees Celsius is, using this equation discussed in the different forms of ideal gas equation, P1 V1 by T1 is equals to P2 V2 by T2. Substituting the values, here the pressure of the gas P1 equals to 750 resulting pressure minus aqueous pressure F into volume 1000 ml. They have given it as, they have given the volume, that's 1000, dividing it by temperature, that's 15 degrees Celsius means 298 Kelvin, and here it's 91.9 ml means volume, and the pressure is 760